A lightning bolt hits the aircraft you're sitting on. You feel it, you hear it, every passenger in the cabin goes silent, and then nothing happens. The aircraft keeps flying. I am a licensed aircraft maintenance engineer. I have inspected aircraft after lightning strikes, and here's what most passengers never understand. A lightning strike is not an emergency, it is a maintenance event. Commercial aircraft are struck by lightning roughly once per year on average. It is not a rare event, it is a designed for event. The aircraft is a Faraday cage. The strike enters at one point and exits at another. The energy travels along the skin of the aircraft, not through the cabin, not through the systems, along the outside. The aircraft is designed to conduct lightning safely from entry to exit. The passengers feel a flash and a bang. The aircraft keeps doing exactly what it was designed to do. Ice is a different threat entirely. It does not strike the aircraft. It builds on it slowly, silently, on the wings, on the engines, on the sensors. Even a thin layer of ice changes the shape of the wing, and a changed wing shape means changed lift. This is why aircraft have anti-ice and de-ice systems. On many aircraft, hot bleed air heats critical leading edges when anti-ice is selected. Heated probes keep the sensors accurate. The crew monitors ice accumulation in real time. And if ground conditions require it, the aircraft is sprayed before departure. An aircraft is not permitted to depart with critical surfaces contaminated by ice, snow, or frost. That is not a preference. That is a rule. Windshear is the most dangerous weather condition on approach. It is a sudden change in wind speed or direction over a short distance. On final approach at low altitude with gear down and flaps extended, the margin for error is small. A severe wind shear can reduce airspeed faster than the engines can recover. Modern aircraft have wind shear detection built in. The system monitors airspeed, vertical speed, and flight path continuously. If wind shear is detected on approach, the system alerts the crew immediately. The response is immediate and non-negotiable, full thrust, pitch up, go around, every time. In 1985, Delta Airlines Flight 191 encountered a microburst on approach to Dallas-Fort Worth. A microburst is a concentrated column of air that pushes straight down and spreads outward on impact with the ground. On approach, the aircraft first hits a headwind as it enters the microburst, then a sudden tailwind as it passes through. Airspeed drops fast. The aircraft lost airspeed rapidly. It could not recover. 137 people died. That accident changed aviation permanently. After Delta 191, wind shear detection and alerting became a major regulatory and industry priority. Airports received better detection equipment. Aircraft warning systems were improved. One accident, one industry response, the system learned. Now let me tell you what happens on the ground after a weather event. After a lightning strike, the aircraft does not continue flying until it has been inspected. Every exit point is located and examined. Fuel caps, antennas, static wicks, fasteners. Burn marks tell us exactly where the energy left the aircraft. After a hail encounter, every leading edge is checked for deformation. After a severe turbulence event, the aircraft undergoes a structural inspection. After an icing event and abnormal conditions, the probes and sensors are verified. Weather does not just affect the flight, it generates a maintenance record. Every event, every inspection, every sign-off. You thought weather was the enemy of aviation. It is not. Weather is a variable that aviation has spent decades engineering around. Every system on that aircraft, the anti-ice, the wind shear alert, the lightning protection, exists because of a specific weather event that happened and was never allowed to happen again. The aircraft you fly on is the product of every lesson the industry has ever learned. Lightning, icing, wind shear. 3 completely different threats, 3 completely different engineering solutions. All of them designed, certified, and verified before the aircraft ever entered service. The systems do not hope the weather stays calm. They assume it will not. Every sensor, every heated surface, every alert threshold exists because engineers decided that weather would never be a reason an aircraft could not fly safely. When you feel that lightning strike and nothing happens, that is not luck. That is 50 years of engineering. Weather does not ground the system handles weather. Weather does not win. If you want to understand what's actually happening every time you fly, subscribe. See you in the next one.